Now I would like to welcome titled Hydraulic Alterations under Climate Change, Global Scale Challenges and Opportunities for Adaptation and Sustainable Development by Professor Rajib Maity at IACSD 2020. I request Archana to introduce the keynote speaker to the gathering.
Thank you, Soumya. Hi, Archana. We are Assistant Professor, Department of AI and ML. Take immense pleasure to introduce our key speaker, Professor Rajib Maity. Rajib Maity is a professor and A.K. Singh Chair Faculty in the Department of Civil Engineering, Indian Institute of Technology, Kharagpur, India. Recently, he became a Fellow of the Royal Meteorological Society, United Kingdom. Some of his other professional recognitions includes Humboldt Fellowship, Experienced Researchers, Germany, James Rennell, Ministry of Earth Science, Young Fellow, MOES, India, Emerging Leaders Fellowship, Australia, Boycast Fellowship, India and USA, IEE Young Engineers Award, DAAD Fellowship, Germany, International ICE Warm Fellowship, Australia, and so on. His research area includes hydroclimatology, climate change impact on water resources, analysis of hydroclimatic extremes, sea level rise, remote sensing applications in hydrology, AI and ML applications in hydroclimatology. So it's a great honor to have you as on the key speaker for the day. We look forward to your presentation, sir. Thank you all.
Yeah, first of all, I practiced to say very good morning to all of you, but here I changed it. A very warm afternoon to all of you. And you know that from the morning, all those lectures that we have heard so far, we have learned about many challenges, right? Now, can you say what is the challenge at this moment for me? The challenge for me is that standing between you and the lunch, which is the most timely challenge that I have to face. So what I was thinking is that I'll definitely show you some of the concept, some of the ideas that what drives the climate change and the impact that when we are talking about some of the basic fundamental science that is coming up or maybe in the near future that will take up the thing to get some sort of insights that what are the things that is going on in the background that we are talking about so much about the impact of the climate change in almost all facets of the life. The idea here is what I am trying to talk about is the alteration of hydrological cycle. So all of us more or less know, even from our school days, what is hydrological cycle. Now what we are going to talk, what the concept that is coming in, it is being altered. Altered, I use the word specifically because it can be intensified and in many places it is happening so, and it can be slowed down also just to make the balance. Now, this is the overall talk about. There are multiple slides are there, multiple background concepts are there, but in the nutshell, what I'm going to tell you, and finally I'll take you to the fact that what are the possible impacts that it can come. Can we get some answers to the issues, to the observations that we can see nowadays? For example, we all know the impacts are already known from the morning itself. We are listening. Extreme rainfall, flooding, then droughts, then so many hazards are coming. Even there are very recently we have seen so many extreme events are happening. Can we get some sort of answer from that, this new or I'll say the newer concept of the alteration of hydrologic cycle? Now, I hope my voice is not too much of fluctuating, right? So when I rotate this side, so very general slide that we are talking about, that this impact is everywhere. I don't want to read, you can see that one, what are the different areas that we are getting the fact. But the question here is that the second one, that is the hydrologic cycle altering due to the possible impact of the climate change? Then we can get lots of answers to this question. There is definitely the interplay, the interaction between the greenhouse gases, aerosols, surface albedo that alters the radiation pattern, that affects the evaporation, and finally it affects the precipitation also. Now, if these things are changing, the altering, then the effect differently at the different location is bound to happen. This is the overall idea about this entire research domain, and we are trying to get some answer. So there are three things that will come up. But before that, I thought that audience might be more general, comparing that it is a civil engineering part. So I will just slightly give you what we are talking about here, though many of the eminent speakers that are sitting here, they already know these things, but just for the targeting the students, I am just taking the few introductory part. So the climate change is no longer remain a debatable topic that we have already seen. Maybe the 10 years back, there is still there was a question, but now it is not. Now, if nowadays the most important part, most good thing is that even our students, if you open the newspaper every day, you will get some sort of news which is related to the global warming. Now, yesterday also you have seen that WMO has announced that El Nino has started, the onset of the El Nino has been declared. So we all know that what are the effects. So the thing is that what is important is that there are so many news, and it is now, I should say, as compared to the 5 years or 10 years back, it is easier to take the general mass, general population on board, and that is very much necessary to tackle many of these issues. Now, if I say that what is climate change, there are different definitions are there, say from the IPCC or from the UNFCCC, but you remember as a student, there are two different terms. All of a sudden, one day, if you face too much of warm, too much of hot weather, if all of a sudden one day you get too much of rainfall, don't call it as a climate change. Because when we talk about the climate change, there is a difference between climate change and weather change. So the weather and climate, which is the one is the instantaneous and climate is the long-term part. So the definitions more or less is covering that one. It's a long-term change, and that is why we are more worried about the long-term slow change may be sometimes irreversible, and that may cause some sort of longer-term effect. Now, if you just see that what is starting point, the global warming we all know, and there are some different parts, how it has been increased, that has been shown. Now, these things, when it is increasing, now this increasing part is causing that global warming that we know, and it has the impact of the different areas starting from the ocean heating, glacier melting, sea level rise, all other parts is there. But most importantly that I am going to focus on this circle is called the intensification of the hydrologic cycle, which may have impacted much of the things. Now, taking that intensification of the hydrologic cycle, that are the many recent time evidences, short-term huge rainfall is being realized that we already know. When we talk about that this warmer climate, when we talk, it increases the moisture holding capacity. So if you increase the atmospheric temperature by 1 degree, the atmosphere can hold more water vapor. But it is not that it can hold, it has to release also. So in the form of a short-term intensified rainfall, it is coming down again. So the more then it will cause more evaporation, evapotranspiration. More evaporation leads to again more rainfall, that will leads to the more runoff. So entire circular part may get enhanced. If I just talk about even the 1 degree or 1.5 degree temperature increase, which might have already done, now our target is to whether we can limit up to a certain threshold or not. So climate change, it goes to the intensification of cycle, global warming, more evaporation, evapotranspiration, increased moisture holding capacity, more precipitation, more runoff, and it goes back. So how this entire cycle gets modified. Now there are different parts. We don't have to see these figures. We have seen in many parts of this one. So extremes are increasing, droughts are increasing. There are different the flood events, very recent decades. If you see, there are lots of incidents that we have observed. So the deaths by the natural disaster, if you just see, the flood constitutes the most from the maximum percentage, and that too in the recent decade, the last decade, how many folds it has increased. This is one side of the extreme. Other side is that the drought pattern also. Most of the Indian basin has shown in future how much the agricultural stress, agricultural drought will be filled up. So both sides of the extremes are being filled up. So the major issues and challenge that we are talking about is the how this global scale changing scenario or the global or of the climate will manifest in the smaller and the temporal scales. So I'm not going to read out all these challenges and all, but here just I will not take longer time. As I told you, the most important challenge now is that to stand between you and the lunch. I don't take more time. But the thing is that three different things I will touch upon. One is called the intensity and frequency, how they have changed for the entire India. Second thing is that one term called the PMP, probable maximum precipitation, how it has changed globally. And third one is that there is a relationship between intensity, duration and frequency. Can this climate change is changing? Can I just see how the map of India has changed? And can I boil it down to my particular city, Kolkata, Mumbai, Bangalore? So if we can boil down to the effect in terms of the intensity, then that will help us to develop or build the sustainable infrastructure that will be able to take care of this adverse effect of this climate change. So three major things. There may be something 30 slides or so. I will not read all the slides. I will give you only the major content that we have and my research group has found out in the recent past. So the future projected part, if we just talk about, there are two things are there. Remember that if there is there is a 100% change also in the Rajasthan or the extreme part where there is no population, the impact on the society may go on not realized. But if the same thing happens in a very highly populated area, that will be affecting more. So that's why there are two components are there. Not only the climatic exposure, the societal vulnerability is also important. So these two things should be compared. But when we talk about the societal vulnerability, its quantification, its availability of this data, the reliability of the data, lots of questions comes in, but they do have a closer link. When we talk about the climatic exposure, it helps to identification of the most responsive region. So which part of India is going to face the heat more? Okay, that's the question here. Not going into details. These are called the general circulation model. There are many such models, about more than 30 models are there, and it is called the multi-model average approach, so that you can take the output from the different models and do the things whether they are agreeing or not. So not going into the details of those things. Another thing for those the uninformed, there are IPCC has identified different pathways that will follow in near future. Okay, those are called the socioeconomic pathways. Earlier we call it the representative concentration pathways, but that has been modified in the phase 6 as this shared socioeconomic pathways. So it takes consideration of multiple issues to decide, and the three major parts. So if we follow different paths, that's the carbon dioxide concentration will follow different parts. The most worst condition is this one. We call it as a SSP 585, and the moderate one is this. There are other paths as well. And just to discuss this particular thing, we can just see for the near future what is going to happen, and also the far future what is going to happen. These GCM simulation outputs are given up to the end of this century. Not going into the details, I can just show you some of the result first. So this is one type of zonation characterization that is differing little bit from what is our India Meteorological Department has. So what they have done is that they have categorized this entire southern peninsula as a single region, which is, that cannot be reliable much, because the western coast and this peninsular part is significantly different so far as the rainfall pattern is concerned. So I'll come to this one, how this zonation has been come, but this is one is that both the things as considered, and we'll just show that one. One is that it is called the mean annual precipitation, other one is the seasonality. Not going into the details of this mathematics, just want to show you that how these things can change. In the x-axis, if I put that apportionment efficiency and the annual precipitation, there are 4 categories you can do: low seasonality, high seasonality, low rainfall, high rainfall. 4 regions are possible, and like this. Similarly, if I take another one, there are many parts of India which receive very huge rainfall. Then there will be 6 such regions will come. And you see that's western coast, even from the Kerala to this Karnataka and Maharashtra can be separated out which is definitely is needed. So this kind of zonations are also needed. At the same time, our reliability of the data from this part, the very northern part of India, is not that much, we are not that much confident. Maybe from this analysis, we are just keeping that one aside to identify which part of India will going to be the more hotspot kind of thing. So again, these are the things, the hotspot calculation. Calculation wise, I am not going. So the idea is that how these things are changing. There are three types of change can happen. One is that change in the seasonal pattern, whether the season has changed or not, change in the extreme, whether extreme rainfall pattern has changed, and change in the monthly pattern has changed or not. So January to December every month if we see. So very quickly I'll just browse through these things. So first category is the change in the seasonal precipitation. So if I just see that and all those different zones, and this is all India. So there are two different scenarios are there, 245, 585. 585 is the worst scenario. And how much is the change in the millimeters? So near future 148 plus minus 110. So 15.5 plus minus 9.5. These are the change that is showing, and this is the trend how it will change considering the all India part. Now there are the different regions, different zones are also shown. This zone 3 might be looking very high, but when we calculate the percentage is low. That means this is already receiving high rainfall zone. Anyway, our main focus will be there on this, how much it is expected to increase in different parts of this India for annual precipitation. Now I go to the second one, the summer precipitation. Third one, monsoon precipitation and post-monsoon precipitation. Summarizing on the winter one, summarizing all these results, it is shown here so that you can see these numbers is basically quantifying that what our GN circulation model, if we just downscale and show you that how much changes is there. So there is an increase, and how this increase will happen, that is shown in this seasonal part. If we do an analysis with respect to the density function, not going into the details of this one, but what you can see is that this blue one is the existing one, and this red dot is the worst case future scenario where the peak has also shifted towards right. So this indicates that the extreme, so this part is extremes events are going to increase in the future part, which is evidence from this CMIP6 simulation data from these different GCMs. And this is for the all India. Again, for this, the daily precipitation, the extreme one, the similar analysis for different parts has been done, and here also for each day, this the fat tail of this red dot is indicating that how much it is going to increase with respect to this blue part, so far as the daily intensity of this precipitation. Am I taking too long time? Just some more time. So again, as I told that in the different region how they are increasing for these different months also. So you can see that this is the existing one, and this is how it is going to increase for the different scenario in the near future for different parts of this India, different zones of this Indian context. Identification of hotspots from that region, we have just identified and categorized into 4 different parts. The entire histogram is divided into 4 parts: highly vulnerable and the less adversarial. So red is the most vulnerable part, and the green is the lowest one. If I say this one, we get this kind of map. So the western part of India and the far northeast is the most susceptible one. And if I just go to this different other factors, the social factors also, if we just take into the consideration, we can see the all tier 1 cities with more than 1 lakh population. There are total 493 cities are there. 34% of this 170 cities are identified as the hotspot cities already. Similarly, 89 cities with that, those are having more than 5 lakhs population. 36 cities are identified as the hotspot cities. Ranking wise, we have given the rank up to 36th city, and these are the most vulnerable cities in India. Second thing is that how this intensification might have caused the change in this precipitation pattern in the past that we can show. I'm just rushing out all this background discussion and just want to show you how these things in the global pattern, how it looks. So global pattern of this annual precipitation and their seasonality, if I just take this entire globe now, it looks like this, and here we can go for a 9 different zones, is that low, moderate, high, and similarly this side also low, moderate, high, and then we can show that 9 different colors and take the globe here and show that where are those, this color corresponds to which region. So you can easily name this 9 zone with respect to the seasonality and total precipitation. So the low precipitation, low seasonality, moderate precipitation, low seasonality. So 3 different attributes for 2 different characteristics, and it leads to the 9 different zones all across the world. And how they are going to change, that is the important part of it. There are some calculation, the way we show it, how we get up to this calculating part. As I told that the intensification of this hydrologic cycle increases that probable maximum precipitation of a particular region. For a particular location, I just explain it here, methodology, rushing up to this part. So these are some modified approach that we have proposed, and it is already established, and this is how the comparison looks like. And there are some average percentage of increase in the mean is 6.73% has been increased, and this percentage of the area where it will increase is 67.28%. So most of the landmass over the world will show an increase in this PMP part. There are some part it will decrease or remain same, but the most important part is a much more than 50%, more than half of this landmass it is going to increase. And similarly for this, their standard deviation is also going. This is the standard deviation. Standard deviation is the second moment, but it increases at how much the short-term intense rainfall also will increase. Otherwise, this standard deviation won't have increase. And these are some of the continent-wise analysis, which continent is going to be affected more, and how these things are going to change for these different parts of this world. So here, this is another one. I am not going to into the details. It is called the longitudinal average of this entire landmass. What is happening? The entire convergence zone is going to shift it towards the up. Maybe that we can discuss in some other time. So, but the average percentage increase in the probable maximum precipitation is 25%, and the landmass over which it will increase is 76%, it is more than the 75% the probable maximum precipitation will increase. Second one is this intensity, duration, and frequency. This is the 3 different characteristics of a rainfall, how these things are going to change due to this intensification of this hydrologic cycle. And again, there are 3 scenarios are considered. This is the most worst condition, and we need that 1 hour duration rainfall. That's why we cannot use the traditional IMD data. IMD has recently published a data which is a daily data, the Indian monsoon data analysis and data assimilation and analysis. This has come very recently. Earlier we generally use that European, the ERA 5 data. So we compare both the things and we got this result. Our main focus is towards this, what is going to happen in each and every changes. So here you can see that 4 different metro cities I have just considered, and shows that how this intensity and durations are going to change in these things. And also it is not only in terms of this percentage how much it is increasing, we can even show that this is the existing relationship between this axis is duration, this is the intensity, and how they are going to change for a particular city like Kolkata. Like this, we can identify that what is the change in this intensity and frequency for each and every location, because it is a spatial analysis all over the India, and for each and every grid I can identify that. Here I am just for the demonstration purpose, I am showing you Kolkata, and this is the Mumbai. So this information, what is the possible intensity that can come in future, that is definitely a information to the water infrastructure design that will help us to develop some sort of sustainable infrastructure. I think I just try to give you a little bit of this overview of what is the intensification of hydrologic cycle can cause, and that is how the climate change impact can be really kind of assessed, or I should say the quantified, and that quantification can be utilized in some sort of design purpose. With this, let me thank you all for your interest. There are some further reading, some journal articles are there. This is my book. The second edition has come on these different methods have been utilized from there. And thank you once again.
I have read in some GSI report that for the past 7 years, 59% of the landslides across the country that has happened in the state of Kerala. So we were doing some kind of analysis. So I think it could be connected to the erratic rainfall distribution, because we have seen that 2018, after 100 years, that kind of a flood happened. So from your studies also I was trying to locate actually, but I could not make out. So is this actually due to climate change, or is there any other factors also contributing? Because we are seeing that continuous rain in just a few hours, now few days rains we are receiving.
Yes.
Or is it irreversible kind of trend, or it is only climate change impact that is contributing?
Yes, this is definitely true as you are guessing, and I have shown you that some of that very initial part, those are some of the slides I just skipped. The thing is that if you just take the last decade, 2011 to 2020, this nature, the things are increasing that we are talking about, but the last decade has shown the maximum increase to this one. The number of flood incidents and number of the drought pattern also that I was showing very initially to develop the motivation why this kind of analysis and this intensification of hydrologic cycle is indeed important, is basically the reason is this one. The reason is that when there is a warming, the atmosphere increases its water holding capacity, and all of a sudden that leads to a short-term intense rainfall. And that has become a very, very frequent now in the name of maybe the cloud burst and those things. So definitely that will have some impact, as I was telling. So if I can quantify that, what is the amount of the increase, then that will be definitely a big input to the geotechnical engineer. They can see that what is the impact of the enhanced rainfall pattern on the landslides and all. And which is definitely true. It has increased even in the last decade. Is a kind of, I should say, earlier we generally say that this century, now the day by day is the intensity is increasing.
Thank you so much, sir. Now I would request Department of IAC HOD to felicitate Professor Rajib sir on behalf of Jyoti Institute of of International Conference on Interdisciplinary Developments in Civil Engineering for Sustainable Development 2023. We look forward to see you all at the valedictory ceremony at 3:30 p.m. tomorrow in the auditorium. Have a good day.